So now the last topic of GOC, which is the basic strength. So what happens over here normally is you have your H plus. This lone pair goes here, you'll form B plus H. Right. So base obviously wants an H plus. So here's this lone pair over here. So this part is called kinetic basicity. This is called thermodynamic basicity. Right. So how we compare the kinetic basicity obviously is the lone pair availability. Now the various way of checking this first is, and you have to follow this order itself for checking, is aromaticity, which we have covered properly. So let's take an example. Right, and let's say H. So obviously this is aromatic. It's a lone pair is used in this, so its availability will be less. So it's this. Okay. Second is resonance. It's like this. And H2. So obviously first case is aromatic, so obviously third will be the least. Now we check in these two. This one is in resonance. This one, second one is non-resonance. This one is resonant. So second year and this is first year. Sorry. First year and second year, because the lone pair is being used, right? The first one, so it's less basic. Let's take another example for resonance. Right, lone pair. Lone pair can go here like this, but even this phenyl group can contribute in the resonancy, but over here only N is contributing. That means the lone pair is less available in this case. So it's like this. I hope you got what I'm saying. Now third one we check is percentage S character. So how do we check percentage S character? First of all, it's S, SP2, SP, so obviously it's more like this. So as percentage S character increases, electronegativity increases. So what's the order we take? Let's take an example so I can explain it. CH2, NH2, CH, over here, C, N. So it's gonna be 1, 2, 3, right? That's it. Next is SIR effect, which is steric inhibition resonance. NO 2 N O, and let's say you have N H H. Over here there'll be hydrogen bonding with this, right? It's all minus M groups, minus M, minus M. So the lone pair is restricted due to hydrogen bonding here. Let's take a case over here. N M E M E, and the same thing we have over here. Over here is not there in what do you say, hydrogen bonding, and this is causing steric crowding, right? So this flips this like this, which makes the lone pair not in resonance with the ring. Lone pair not in resonance, whereas here lone pair is in resonance. So this is the order. Next is ortho effect. NH2 CH3. This is a weak base. Ortho substituted anilines are weak bases except with an OH or OMe at ortho. Remember this. Okay. Next we check is Brett's rule. So what does the rule say? First of all, let's draw the compound. We have to draw a bicyclic compound. Right. So over here, this cannot be planar, or like 120 degrees, like over here, this one. If total atom in bicyclo are 8 or less. Okay. So let's take an example. Okay. Take this and let's take this. Right. This lone pair can attack here. But if we attack this lone pair for resonance, what will be forming is, let's check it. We're forming a double bond here, O minus here, plus here. This is not allowed as it's sp2, which is against Brett rule. So lone pair not in resonance, which makes it more basic. Right. So what number was that? This was 4. This is 5, 6. 7th is plus and I and minus. Plus minus I and plus minus M. That's what you check here. Explain that properly, you don't need to solve it. Next is flipping. Let's take this as a lone pair here. R1, R2, R3. Now there's a phenomena called tunneling that makes this lone pair start moving to smaller orbital. So let's check. At one point, this compound will be a pure p orbital will be formed here. Pure p orbit. This is right. And later on, what will be forming is n like this. Now it will obviously push this up. R1, R2. Right. So this, as the lone pair is going through this tunneling effect, is obviously lone pair ability is obviously going to decrease. So basicity decreases. Right. So this is all you need to know for basis acidic basis string. Let me just do what all we're going to cover. After this is, I think it's going to be Peter Sykes reading, and we're going to do some question solving, advanced level. We'll do advanced PYQs, okay? Plus one book I have, we'll solve that. Okay, thank you.